Welcome to The Explainer. Today, we're going to go way beyond just writing simple prompts. We're diving into the future of building with AI, and that future is called context engineering.
So, have you ever felt this? You're trying to get an AI to do something actually complex, a real world task, and it just falls flat. Maybe you're asking it to fix a tricky bug in a huge app. You give it the prompt, but it's like it's missing the bigger picture, right?
Well, that's because you're really just giving the AI a single instruction. And look, that's the heart of prompt engineering, right? You're telling the AI what to do in one shot. It's powerful for sure, but it has some serious limitations. But to build really powerful applications, you've got to give it more. You need to give it a whole system to work with. And that, right there, that is the huge leap from basic prompting to what we call context engineering. It's really the difference between just giving an order and creating a true collaborator. Okay, let's get into it.
All right, so let's break this down. What's the real difference between a command and a collaborator?
Okay, check this out. On the left, you've got prompt engineering. That's a single instruction, good for a simple one-off task. Think, fix the bug in this one file. But on the right, with context engineering, wow, we're talking about providing an entire information system. It's not just one file, it's multiple sources, tools, memory, history. The example totally changes to fix a bug by understanding the entire codebase. See the difference? It's not a request anymore, it's a mission. So let's get a solid definition here. Context is the complete set of information an LLM needs. And look what that includes. It's not just the user's request. It's the system prompt, the tools it can use, its memory, stuff it retrieves, the conversation history. It's literally the whole universe you create for the AI to live and work in.
So, to really get this right, you have to start thinking like a context engineer. And that means understanding the 5 core principles, the foundational rules for building the stuff.
Principle number 1, and this is so important. Everything must be explicit. The model only knows what you tell it. Period. It's not going to guess anything about your project. I mean, think about it. The model has no clue about your project's architecture, right? It doesn't know your company's specific coding style or conventions. You have to spell everything out because it will not assume anything. If it's important, you have to put it in the context. Okay, principle number 2 is a big one. Context is finite. Every single LLM has a hard limit on how much information it can handle at one time. We call this its context window, and it's measured in tokens. So what does that mean? It means you have a budget, a token budget. You have to be smart about how you spend those tokens. Just look at this sample allocation. A big chunk for memory and retrieval, some for tools, some for history. It's a constant balancing act. And it's not just a technical thing, it's an economic one too. Every token costs you. So you're always asking, what's the most valuable information to include right now? All right, principle 3. Position matters. It's not just what you put in the context window, it's where you put it. This can have a huge impact on how well the model performs.
Yeah, there's this fascinating research concept called lost in the middle. It turns out models pay way more attention to information at the very beginning and the very end of the context. So what's the takeaway? Put your most critical stuff, like your main instructions and system prompt, in those prime real estate spots, the start or the finish.
Next up, principle 4. Freshness matters. This one just kind of makes sense, right? In a long conversation, the model is going to pay more attention to the things that were said most recently. It's just like a human conversation. And that brings us to our 5th and final principle, which might be the most important of all. Quality beats quantity. Seriously, don't just cram stuff into the context window just because you have space. More data is definitely not always better data. This slide says it all. Look at the difference. On one hand, you could dump 50,000 tokens of kind of sorter-related code files on the model. It's just going to get lost in all that noise. But on the other hand, what if you give it just 100 tokens of the exact function it needs? The result is going to be so much more accurate. Being precise is always better than just being loud. Okay, so we have these 5 principles. How do they actually come together when we're building something? Well, they form what we can think of as a 5-layer stack. This is basically the blueprint for an AI system. And you build this stack from the bottom up. You start at the foundation, the system prompt. That defines the AI's personality, its rules, its goals. Then you add a layer of tools so it can actually do things. Then you add memory so it can remember what's happened. Then retrieval so it can go find new information. And sitting right on top, you have orchestration. That's the brain of the operation, managing everything below it. So
Let's see how an AI agent actually uses this stack to get something done. It's not a one-and-done thing. It's a continuous loop, a cycle of thinking and acting.
Here's how that loop works. First, you give it a request, right? Fix this bug. Then, the agent assembles its context. It pulls from all 5 layers of that stack we just talked about. Then, it makes the API call to the LLM. The LLM thinks and decides on a plan, which might involve using a tool. So the agent executes that plan and observes what happens. And then it loops right back around with this new information, repeating the whole process until the job is done. Okay, this brings us to the big finish. Why does all of this change everything? Because it really is a massive shift in how we should be thinking about building with AI.
This quote really nails it. The orchestration layer is where context engineering becomes system engineering. Once you're managing all these pieces, the tools, the memory, the planning, you're not a prompt writer anymore. You're a system architect. You're designing an intelligent system.
So here's the bottom line. Prompting is just an instruction. But context is a system. And if you want to build reliable, powerful AI applications, you have to design that system. You have to think about the rules, the memory, the tools, the whole shebang. So I'll leave you with this question. The next time you build with an AI, are you just going to be writing a prompt, or are you going to be designing a system? Because that question right there is what's going to drive the next wave of innovation. Thanks for watching.